Alright, so welcome back to another episode of Code with Akya. Today we are going to be exploring an essential concept in graph theory, topological sorting. So this sorting is crucial when dealing with tasks that have dependencies, like scheduling jobs, ordering courses, or resolving package dependencies. So we'll go over the intuition, the algorithm, and how to implement it in the Python. So let's get started with it. So, by definition, topological sorting is the process of arranging the vertices of a directed acyclic graph, the DAG, in a linear order, such that for every directed U to V vertex, U comes before V in the ordering. So, in simpler terms, it's like figuring out a sequence of tasks where some tasks depend on the other being completed first. So, if you complete the A, then only the B will be executed. So, this is how they create the dependencies. So, however, topological sorting only works on DAG because of the presence of the cycle would make it impossible to arrange the vertices in a linear order. So now let's just discuss about how topological sorting actually works. So there are basically two common ways to perform topological sorting. One is CAN's algorithm and then there is DFS algorithm, the depth for search algorithm. So first, CAN's algorithm, which is called as using in degree algorithm. So this method uses in degree, the number of incoming edges, to track vertices that can be processed. So we start with vertices with 0 in degree and process them and reduce them in degree of the neighbors. Then there is the depth first search approach. This approach uses the depth first search. Once a vertex has finished processing, all of its neighbor has been visited, it is added in a topological order. So that sounds pretty simple, right? The depth first search sounds pretty simple. So we're going to be using that particular approach. So let's just look at the pseudocode of it. So this is the pseudocode of depth first search. Okay, this is the pseudocode of topological sorting in depth first search based. So you can just pause the video and can observe it, or you can just write it down if you want to. I'll highly suggest you to write it down so that you can at least look at it whilst you code. Because having a pseudocode whilst you're coding is fantastic. Alright, so let's just move on to the coding screen now. Alright, so first we'll be importing certain libraries. Or not certain libraries, just one library we want. From collections, import default dict. Basically a default dictionary. Then we'll create a graph class to represent a directed acyclic graph, the DAG. First thing, adjacency list will be created with self.graph and then the number of vertices, self.v, right? These are the two arguments that we need in the initialization function. Once we have that, we are going to be creating a function add edges. So why do we need an add edges? The function is used to add an edge to the graph, as the name says, right? Then we need a DFS based function to perform topological sorting. So topological sort util, 4 arguments, self, v, visited, stack. And inside of it, we'll mark the current node as visited. So once this function is executed, the current node will be marked as visited. Then we'll recursively perform this again and again for all the neighbors of the vertices. For that, we'll run a for loop. If not visited, we'll just keep it as simple as possible. So if not visited neighbor, then self.topological sorting sort dot underscore util will be this. Okay. Then we'll push the current vertex to the stack. So once it is visited, push it to the stack. Right? Now, once we have visited all of them, now we have to perform the topological sorting. So now we'll mark all the vertices as not visited. Then pick up an empty stack. Now call the recursive helper function for each unvisited vertex. And once done, we'll print the content of the stack in a reverse order. So once we're done with that, our topological sorting is basically done. So now we have to create an object of graph G and then add the edges. All right. So you can put on the data on any of the graph visualizer, maybe if you can find it online. Then you can just put on all of these values and you can see visualizations of what exactly it would look like. So now let's just print the topological sort and we'll be able to see the output. So output will be a simple list which will have the sorted, or not precisely sorted, but topological order of the task, ensuring that dependencies are respected. And you can see 432310, and that's exactly how it was supposed to be. So that was all about topological sorting. Whether you are managing tasks, organizing dependencies, topological sorting is a powerful tool. It's a simple and efficient way to ensure that all the tasks are completed in a correct order. So if you like the video, put on a like. If you dislike the video, put on a dislike, and don't forget to subscribe. Code with Hakya. So stay tuned for the next video.